Welcome to qnawire.
In this problem, we have to find the relationship between two satellites in orbit around a planet, given that we know the relationship between their velocities. So the first thing that we should do is rewrite an equation for the velocities so that we can relate them in a more meaningful manner, and not just in terms of two variables that we don't know the actual value of. So we do that by first writing down that we know that for any satellite in orbit, the gravitational force is what creates the centripetal force. That means that our gravitational force, where m is the mass of our satellite and big M is the mass of our planet, this equation has to be equal to this equation for centripetal force. We can rewrite this so that we get a relationship for V, and that's going to be that V is at big M times G over R. Now, this is useful to us because big M and G are constants that will cancel out when we try to find the relationship between the periods. All right, so now we can find an equation for our period that has that relates the period and our velocity, since our period is what we're actually looking for. Now we know that t is equal to 2 pi r over v. And we just found an equation for v, so we can rewrite this as 2 pi r over the square root of big M times g over r. And we can rewrite that a little bit more elegantly to be 2 pi r to the 3/2 all over the square root of g times me. All right, so now let's try and relate our periods. Well, if we have ta over tb, we get that those are equal to what we just found, 2 pi ra to the power of 3/2 over the square root of g at big M, and that all over 2 pi rb to the 3/2 over the square root of gm. All right, so as I mentioned earlier, all our constants are going to go away because they're the same no matter the scenario, and we're going to get that ra over 3/2 is equal to rb over 3/2. All right, so this gets us one step closer. Let's write our equation for the ratio between our periods again. Ra 3/2 over rb to the 3/2. 2 is a little messy. Okay, well, we don't know our equation, we don't know our ratios, but we can relate them using that same equation for the period from earlier. We know, like we said earlier, that v is 2 pi r over t, and that means that r is equal to 2 pi, that means that r is equal to vt over 2 pi. And even though we don't know our velocities themselves, we know that relationship from earlier, that VA is 3 times VB. So we can rewrite this equation once more. Now we can say that VA times the period of A to the power of 3/2 all over 2 pi, and that's to the power of 3/2 as well, let me make that clear, over VB TB 2 pi to the power of 3/2. All right, so now all that's left for us to really do is simplify. We can cross out our 2 pi since those are just constants, and we get the following. And from here, we can we can rewrite so that TA over TB is V cubed B over V cubed A. Now we know the relationship between VB and VA. So this is going to be V cubed B over 3VB cubed, which is going to give us a final result of 1 over 27th. And that is going to be the relationship between our periods.